So the first thing we'll do is we'll think what's going to happen to sine of k pi on 2 and x to the power of k as we vary k itself. Firstly, x to the power of k will be nice and simple. X to the 0, x to the 1, x squared, etc, etc. When we look at the sines, the operand of sine here, the k pi on 2, firstly we'll get 0, then we'll get pi on 2, and then we'll get pi, 3 pi on 2, 2 pi, etc, etc. So if we think about what that will give us in terms of sine, well, sine of 0 is 0. Sine of pi on 2 is going to give us 1. If we think about sine of pi itself, then that will just be 0. And then sine of 3 pi on 2 is negative 1. And then next will be sine of 2 pi, which is the same as sine of 0. So that will also give us 0. So our integral will now be, when we have an even power, it's just going to be 0. And when we have an odd power, it's going to alternate between positive and negative. So we're going to get x minus x cubed plus x to the 5 minus x to the 7, etc, etc. This then we can evaluate nice and simple. This will give us x squared on 2 minus x to the 4 on 4 plus x to the 6 on 6 minus x to the 8 on 8, etc, etc. Now we could leave this as the answer, but there's a bit of a nicer way to write it. If we remember the Taylor series expansion of log of 1 plus x, that gives us x minus x squared on 2 plus x cubed on 3 minus x to the 4 on 4, etc, etc. So the reason we're going to use this and then why we should kind of be thinking about it is because our powers always match the number underneath. And we have an alternating between negative, positive, etc, etc as we go through. So it must be some sort of link between the two. We can see in the top one, we've only got the even powers. So to do that, what we can do is instead of having just an x here, if we make that x squared, so we'll have the natural log of 1 plus x squared. On the right-hand side, all of our x's will be squared as well. So we'll have x squared minus x to the 4 over 2 plus x to the 6 over 3 minus x to the 8 over 4, etc, etc. And this now is very, very close to what we want. The only thing we need to do is divide by 2. So over 1 here will become now over 2. Over 2 here becomes over 4, over 3, over 6, etc, etc. So looking at that, a half of log of 1 plus x squared, just to double check, but it will give us x squared over 2 minus x to the 4 over 4 plus x to the 6 over 6 minus x to the 8 over 8, etc, etc. So beautiful. Our integral, nice and simply, can be written as a half of the natural log of 1 plus x squared.